I know. So now we'll have to get out at 10:15.
Lucia.
Okay. So for our paper, we were supposed to talk about technology and crap, right?
Mm-hmm.
Is that this one? Report number 3?
Yep.
Discuss problem solving as it relates to technology. Specifically discuss when it is appropriate to use existing tools like Excel to solve a problem versus writing your own software to solve a problem. So, kind of the concept being using the right tool for the job is a large part of being a successful IT professional. So, what do you have to say on this topic? When do you use an existing tool to solve a job?
When it has the functionalities that you need to complete a task or solve the problem.
Okay, does it have to have all the functionalities?
Most of them, or some of them, some part of those, of your task.
Well, what if we took this outside of technology? How many of you have fixed something around the house with a screwdriver, and it was a task that the screwdriver was never advertised to solve? A problem that the screwdriver was never advertised to solve. You've used it to pry something open, or you know what I'm saying, right? You repurpose some other tool to to solve a problem.
Like your container bin, your storage bins.
Yeah, that kind of crap. So let me ask the other side of the question then. When do you create a tool for solving a problem versus using an existing tool?
You can't
If
get
there is a tool, if what you think is not available, then you as per your mind, then.
Okay, so in the obvious case would be the situation where the tool that you need doesn't exist.
Yeah.
So if you want to solve the problem, you're going to have to build it.
Right.
So like if you want to travel over to Europe instantly, we're going to need a teleporter. Can't go to Home Depot and just buy that. So we're going to need to build one, right? So that would be the obvious case. If the tool you want doesn't exist, then you might have to build it. Well, what about if the tool that you want? What if the tool that you could use exists?
Cost $1 billion, you can't afford it.
Okay, could be cost prohibitive.
The time, because sometimes when you build something, it's totally different when you customize something else. Like, you have the tool to build a new phone software to you, or just pay money to get this software.
Okay, well, you started off saying time.
Yeah.
So, what you're saying is that there might be the perfect tool for what you need, and you might need to build that. Or there might be a tool that's pretty close to what you need, and you can just write a check and have it today. So in that particular case, you might choose the time savings of having the slightly imperfect tool over the time you'll have to take and probably more money, the additional cost to build a custom tool. Okay, so and I agree with that, is keeping down that thought process. What point would you go ahead and build the custom tool? When would it be worth it?
I talked about if it would take you longer to figure out how to use the existing tool, then you know that this exists, but you have no idea how to go about putting your information in there. If it would be faster for you to just make your own program because you know what to do.
Yeah, or at least
Yeah.
closer to the same amount of time. If you can have the perfect solution in 10% more time than it would take to learn this other tool,
Yeah.
okay, I think that's fair.
Sometimes for existing tool we can't make the manipulation. We can't able to make the changes on the tool, so we can able to make our own tools or software.
Okay, well, specifically, let's say that you're running your own business and you have to solve a problem. Maybe it's it's a place that people have to book appointments and prepay for their appointments or something like that. A hair salon. Let's say it's a hair salon, and you could go out and you could write your own piece of software for solving that problem. Or if you do a search real quick, you can probably find there's 50 or 60 different options online where you pay a monthly subscription and they already have a website that's done and you can customize it, putting your business's logo up there and all this stuff. You can drive your clients to that website and all that jazz. Obviously, from a time perspective, the quickest way to get your business started would be to use an existing tool. If you're in the business of cutting hair, the last thing you want to do is start writing software. You want to be able to start focusing on cutting hair. What would be a reasonable argument? So let's say we start that day one. We're using an existing tool. We're paying our $50 a month for it, whatever it is. At what point would it be worthwhile to create a custom tool? Something that's very specific to exactly what we need. Because very likely that tool for that $50 a month we're spending on that subscription, very likely that tool, if let's say we needed to do 10 things, it probably does 7 of the 10 things we need, and then it probably does an additional 30 things that we don't need. And probably at least one of those 3 things that it doesn't do, we really wish it did. So at what point would it be worthwhile for you to create that custom tool?
Yeah, for example, if you take the Excel, okay, and yeah, we have the rows and column. If you're going for the database, if you like organizing the huge company, maybe like Excel will not suit, so you need to go for the database like Oracle or someone. So I prefer to go for like I prefer to develop the suitable software which can use the more database than Excel.
I mean, the goals of the point is like the kind of benefit to work with your own software because you know your organization, you know your like company what they are looking for, and you are looking to if you have like far vision for your own software, that means the kind of problems you have the own software can help you to solving your problem. You're not going to wait for another party or out of your company to help you to get this problem solved.
Well, right. So, but that's the beginning part. That's when we're paying this $50 a month for this other tool. But at what point do we go ahead and make the decision that we're going to create our own product?
If you are going like to sell this product also beside you.
Okay. So one argument might be that you decide to create another revenue stream for your business where you're going to also sell this product. That's not an unreasonable statement. Not the direction I was going, but that's not unreasonable. If you decide that, hey, I really think other businesses could use this, and the solutions that are already out there, they're okay, but none of them do it right. So I'm going to do it right, and then I'm going to sell it. Go ahead.
I think the time and our needs. I mean, if we found, for example, Excel sheet would be prepared for our business, we will use it. But if not, we'll try to create something that we need. It will maybe will save time, save money, save the, So I think the time and our need, that's what do we need to focus for. If we find any access tool, we'll use it, but if not, I think it would be better to create something that what we need.
Okay, so from an IT perspective, kind of a phrase that I always refer back to is this idea of fake it until you can make it. So when you're first starting this hair salon business or whatever kind of business it might be, you don't have $20,000 laying around to build the perfect software for you. What you need to do is you need to get your business started so you can start making some revenue, and then you can turn around, and then once you have $20,000 laying around, then maybe you start working on this product. Maybe you decide you're also going to try to pay yourself back for all these months of subscription by maybe spending a little bit more on the product initially by building it so that you can sell it as a subscription. But at the same time, I might make the argument that if you are somebody who's in the business of cutting hair, you're probably not a person who's going to do that great at cutting hair and selling software. You might bring in a partner or something like that to help with that side of things. But the punchline here is that I think that you create a custom tool to solve a problem when you need to solve that problem many, 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 many times. Okay, as soon as you get down to a situation where you're having to solve the same problem all the time, that's when you create a custom solution for it. Whether it's taking an existing tool like Excel and creating a custom spreadsheet to help you solve that problem, or creating a brand new solution to it from scratch. It's when you need to repeat something so many times that it's worth that one time extra effort, extra time, extra expense to get the correct tool to save you a bunch of time and money moving forward. Fair enough?
Okay, what I wrote in my report, I said one of the disadvantages of one software if you're going to use it one time.
Mm-hmm.
Okay, but
That's the disadvantage of
for
the
one
custom
yes.
software? Okay, yeah, so
Okay, that's-
basically what I just said, the inverse of what I just said.
But there are like reasons, I mean, as you said many times, that means the problem is not like the specific problem. For many problems, like general purpose when you're going to build a new software. I believe, in my opinion, I don't know, but I am making mistake with that. The specific purpose for building new software is going to just solve one problem. Okay. I mean,
Okay.
like many times, that means in the, in the technology and business environment, they're going to change during the like when they're going. Today is not like tomorrow.
Okay.
This year is not like next year. In my opinion, I say like software or to get like existing, software, it will be the perfect for a general purpose for many times. And I'm sure about the first things that's important for the boss, for the supervisor. He said how much the existing software costs us.
Mm-hmm. Well, and even asking that question, asking how much does something cost us, there's two different answers. If you're paying $50 a month for something in perpetuity, that means it's $50 times 12 times infinity years. That's going to cost infinity dollars. If you think you're going to be in business for 30 years, let's say, something like that, then then you can come up with your actual cost for that. Well, there's a lot of businesses that can afford $50 a month that can't afford a one-time downstroke of $20,000. So maybe in the long run, they end up spending more for the product. But in the short run, they can afford $50 a month or $200 a month versus a big single downstroke. So it's not always about the total dollar. It's about a yearly budget. So many companies work that way where it's, you have a budget, you use it or you lose it. Well, you might not have a big enough budget to pay for a giant project on a one-off type thing. But you got plenty of budget to, drop $200 a month for something that benefits your department or something like that. So, there's a lot of variables that play into it. But it sounds like the direction you kind of took in your paper is that you would have to have a pretty good reason to create custom software rather than taking something else out there that really solved the problem at least pretty well. Yeah. I don't disagree with that. I think that you have to have a good reason to create custom software, especially when there's other solutions out there that mostly pull it off. Because we can usually repurpose other things. The example a few minutes ago was, how many different things can you fix around the house with a screwdriver? Screwdrivers and duct tape. You can do all sorts of stuff. I once installed an air conditioning, like a window unit air conditioner, using in a window that was not big enough for the air conditioner to fit in, using a hammer, a screwdriver, that spray foam stuff, and the screwdriver was no longer a usable tool in the end. So I had to use a screwdriver and the hammer to chisel out the foundation to make the window bigger. It was in a basement. So I can get the air conditioning to fit in there. Well, then I needed to use the spray foam to hold the thing open because this wasn't there wasn't a window anymore. This was cement and stuff. So I needed to seal it all up. So I spray foamed all in there. But then to keep the one side kept closing, so I just shoved the screwdriver in there to hold it open. And the screwdriver ended up becoming melded with the foam. It became part of the solution, is what I'm saying. Sold the house that way.
Wow.
That was the same house that had a 65-inch. In that same basement, we had a 65-inch big screen TV, but like not the flat panel ones that you have today, like the big Sony, rear projection CRT things that weigh 400 pounds. And this was one of those stairwells that goes down, then turns 90 degrees and comes back on itself. The delivery guys would not take it down there. We got it down there. Sold that with the house too. That wasn't coming back up.
So these folks got a pretty good and bad deal out of this.
The correct tool for that job would have been to buy a new house. Or build a house and move the TV in as part of construction. Okay, so sounds like that was a pretty doable paper. Lots of decent ideas out there.
Yeah.
Okay, but the programming was easy, you said?
We didn't say all that.
That's not it? Oh, that's this next assignment. I don't want to show you that yet. Oh, that was going to be just a nightmare.
Oh, thanks. How lovely.
So, is this it?
Yes.
All right. What methods do we have access to? So the first one, print vowels. This method should take a string as a parameter and print all the vowels contained in that string, one character per line. So we know the length of a string, and we know the char-at method. That's it? Okay. All right. So let's go write that guy. See, aren't these fun little puzzles? Where I give you an assignment, and in my head, when I originally wrote the assignment, I might have thought you had 5 tools, but then I only gave you 2 tools.
Yes.
I know, it's so fun.
No.
This is the only thing that gets me through this 4-hour class, is I get to come in and do fun problem solving. Is this our code?
Problem solving, all in general. Fun.
Is it us?
Huh?
Ish?
Yes.
All right. Let's get rid of all this crap.
We're looking at print vowels.
Oh man, look at all that awesomeness. Okay, so we want to write a method called print vowels. So it's just going to print something out. It's not actually returning anything. It's going to take a string as a parameter, and we want to go through and print all the vowels. Method should take a string as a parameter and print all the vowels contained in that string, one character per line. Okay, fair enough.
Were we supposed to add the Y in there for the vowels?
It doesn't matter.
Okay.
I'll give you a 0 if you didn't, but it doesn't matter.
Thanks.
Okay,
Right.
so we're going to go through this string, every character in the string. So we're going to need a for loop. Print I is equal to 0, I is less than s dot blank, I plus plus. So this will walk through the string one character at a time. Each character we're looking at, we need to determine if that character is a vowel. Well, how do we determine if something is a vowel? So if s dot char at I, that's a character, right? And I want to ask, is that a vowel?
Equal.
Like that?
Well, you can make it easier and then set a variable equal to each vowel and then just do that instead of having to type out s dot.
Well, I'm gonna do this. This is gonna be cooler.
Oh,
So I'm gonna say static Boolean is val. This guy's gonna take a character as a parameter. And we're gonna say if C is equivalent to an A, or E I O U. Have we looked at the character class yet?
I think we did a little bit. Only a little bit.
Like converting a character to uppercase?
Yeah.
Yeah, we
Yeah,
looked
we
at
did.
that.
with the character class?
Yes, mine
So-
is like,
So character dot to uppercase.
Uppercase.
We know how to do that? Okay. So I'll go ahead and convert C to uppercase, and then we'll compare it. To only the uppercase vowels. That make sense? So whatever C is, I'll convert to uppercase. If it's any of those guys, return true. Return false. You really actually could have returned just this line up here. All in one fell swoop, but this is cleaner. At least clearer. All right, so now we have a function called isVal that returns true if you pass it a char and that char is a vowel, and false otherwise. So inside here, we'll just ask if. Now, is this a class method or instance method?
Instant. Oh, class, because it has
class
static.
set-
Class method because of static. How do we call class methods?
set-
You do the
That's how we
Class.
define it. How do we call class methods?
class dot and then your method.
We call them using the name of the class in which the method was defined. I need to put these into like sippy cups for infants.
I don't think an infant should be drinking soda.
Really?
Yes.
Okay, so we use a class name. So we're going to, the name of the class is hello.
Yes, hello.
So hello dot isVal. I'll pass it s dot char at I. If that boils down to true, system dot out dot println s dot char at I. What if it's not a val?
Nothing.
Skip it. Keep moving on with your life, right?
Yep.
Okay, so that's the answer to number one.
Sure.
So we can go test that real quick. This guy, class method or instance method?
Class.
Class.
Class method. So we call it using the name of the class in which it was defined. Hello dot print vowels. We're going to pass it a string. Pass it elephant. So what you print out E-E-A. Right?
Yep.
EEA. Make sense?
Yep.
All right. So that's print vowels. Next one is print consonants. Ooh, this is going to be an interesting one.
Yeah.
It's the same thing. You can use the its vowel, and if written false, print it.
Just because something is not a vowel does not mean it is a consonant.
I mean, like digits number.
Yeah, like question marks
You
and
can add F F before, like F is vowel, it like bigger than A and smaller than B, bigger than A capital and smaller than B.
okay.
Go ahead.
Okay, so you want to take advantage of the fact that what we talked about last time with Unicode. So we can go through and we can write. So this is print consonants, right? Static void print consonants. Is that right? Consonant. That's a hard
Yes.
word to spell.
Yes,
It
correct.
is.
Oh my gosh. String S. Again, we'll spin through our string. Okay, and we're going to ask if hello dot isVal s dot charat I. If not, if that guy is not a val, we talked about the not operator, right?
Yeah, but I didn't know you can use it on in front of anything.
Well, yeah, so this guy right here boils down to what? True or false?
Yeah.
So not true becomes false, not false becomes true.
Gotcha.
Okay, so this is saying if hello dot isVal is equal to false. That's what this line right here says.
Oh, yeah.
Okay? So if that's false, and now you want to say s dot charat I is greater than or equal to a lowercase a, and s dot charat I is less than or equal to a lowercase z, and
What about uppercase?
you want to do the uppercase versions of those, right?
Because you're changing everything to uppercase.
Well, not in here, I'm not.
Not
In
oh,
here, I'm just dealing with whatever they gave me.
Gotcha.
So I got to check to make sure. The vowels, I check against upper and lowercase by just converting everything to uppercase. But out here, I'm saying, if you're not a vowel and you are a letter, that's really what I'm saying. If you are, you know what? This is stupid.
Yeah, if you do just less than, I mean, greater than capital A, then.
See, that's going to look too complicated there. We're going to write another method. Static Boolean is letter.
Oh no, because if you do greater than capital
No,
A,
we're
then
gonna put
it's
the same crap in here.
automatically-
It's the same thing. Yeah, go ahead.
We're going to put the same crap in here, but now we can just call this function whenever we need to ask if something's a letter. We don't need to write this whole big rigmarole, ands and ors and all this crap. So we're going to take a character in here. We'll say C is equal to character dot to uppercase C. So now we're only dealing with uppercase letters. And we can go ahead and return C greater than or equal to uppercase A and C less than or equal to uppercase Z. We can actually return that value. We don't even need to ask the question. Why is that? Well, if let's say C is a D, uppercase D. Is uppercase D greater than or equal to uppercase A? Yes. Is an uppercase D less than or equal to uppercase Z? Yes. True and true is true. So we'll return a true. Rather than saying, if this is true, return true, else return false. If this is true, return true, else return false. So now we're just going to return what this guy is. If he's true, return it. If he's false, return it. That make sense?
Yeah.
So, and we could have done the same thing with our vowels checker down here too. Okay. So, now for our is vowel, so for print consonant, if it's not a vowel and hello dot is letter, oh, missing a parenthesis here. All right, so for this, there we go. So if whatever I'm looking at is not a vowel, and if it is a letter, then we want to print it, right? Make sense? All right, and let's go ahead and, well, actually, I don't need to copy it. Let's do hello.print consonants elephant. So this should print out an L, P, H, N, T. And what if I put in some capital stuff in there and a couple of question marks and spaces and crap?
It gave you the space too.
I don't think it gave me the space.
Oh, okay.
We're legit. It gave me only consonants. Too legit. Do you know he's a preacher now?
Are you serious? That's weird.
Did you ever? Are you too young to remember him?
No.
You remember MC Hammer
I used to do the dance all the time when I was a kid.
with the too legit dance?
Yeah.
MC Hammer or Vanilla Ice?
Yes.
Which who?
I like MC Hammer better due to the fact that I can do weird dances off of his stuff.
Just dumb.
Hey, I was a kid. Are you serious?
All right, so that's print consonants. 3, print digits. So this should take a string as a parameter and print all the numeric digits contained in that string, 1 character per line. All right, well, so let's go ahead and let's write another function here called static Boolean is digit. Takes a char as a parameter. Return C greater than or equal to 1 and C less than or equal to 9, and we actually need a 0 in there. Like that. So that's is digit. So we'll do static void print digits. Take a string as a parameter. Another for loop for int I equals 0. I is less than s dot length. I plus plus. We'll say if hello dot is digit s dot char at I system dot out dot println s dot char at I. So that's print digits. So I'll just insert some. Well, let's give ourselves a 0 in there somewhere too. So there's our digits. Make sense? All right. And I think the last one was easy, so we don't need to look at it. All right. So who all got the last one working? One person? Nobody else got it working? 1.5 people? It's like, I brought you a hot dog. And cake. And cake. All right, so last one, process expression. This method should take a string in the format of an integer followed by 0 or more operators followed by integers. Your method should then process this expression and return the result as an integer. You must solve this problem using only tools that were taught thus far in CSC 535. So if I pass it the string 125, I should get 125 as an int. Okay, so why don't we start off by solving that problem? I need to have the ability, if I have a string that contains a number, I need to be able to turn that into an int. Okay, so let's go solve that problem. So the thing I want you to see so far here in terms of the patterns, how I'm solving these problems, notice I'm creating a whole bunch of little widgets, a whole bunch of little tools that we can then reuse. Why did I write isLetter as its own method? Because we might benefit from being able to easily ask, is a character a letter? We might benefit from asking, is a character a digit? Is a character a vowel? Make sense? So we're writing a bunch of tools that we intend to reuse. Kind of see how this is related to the paper?
Yeah.
See, maybe I prepared a little more than you think. At least back when I wrote this.
Or dumb luck.
I doubt it's dumb luck because I was probably like procrastinating on this for about 6 months or something, and then finally said we need this done tomorrow, and I finally just wrote the whole course in a night.
Good job.
Man, nobody even looked at it either. Clearly, they would have said that this number 4 was too easy. All right, so, well, yeah. Let's. Everybody have all these?
No, can you copy and paste it?
Copy and paste it into what?
And post it.
I second that.
So you want me to just copy the whole thing and
Yeah, with number 4.
Yeah.
all right. So I should just keep going, is what you're saying.
Yes, pretty much.
I was gonna clean up here. Here, let me just.
No.
I'll just press enter a bunch of times and give myself a little gap. I'm an artist. I need room to paint.
Your canvas.
This is my canvas. What am I writing? Oh yeah, string to int. All right, static int string to int. Takes a string as a parameter, and we can assume that the string we're passing this guy contains a number, and we need to turn that into an int. What's up?
That's what I originally had. Now I changed it back.
We
Go ahead.
haven't written it yet.
No, I mean that. Just even that part, I had it. And then, yeah, go ahead.
This part's easy. Even
Hey,
a Visual
look.
Basic programmer can write this.
Thanks a lot.
All right, so string to int. I need to take something. Oh, here, I'll just do it right here. I need to take something that looks like the string 1, 2, 3, but that's actually a string, and somehow turn it into the number 123. That is something that I could add 1 to it and get a 124. Did we talk about string concatenation last time? Gluing strings together? Okay, good, because this problem would suck if you didn't. Or if I didn't. Okay, so if I add 1 to this guy here, I would get the string 1, 2, 3, 1. As opposed to adding 1 to an int 123, I get 124. Make sense?
Yeah.
So I'm trying to convert, hold on, I'm confused. There.
Put an equal sign in there.
I'm trying to turn this guy into this guy. Make sense? All right. So, how do I do that? Using only what we know from class. Okay, so you want me to go through? Well, let's solve the problem in our head first. Then we'll so how do I actually solve this problem? Step 1 is what? How do I convert the string? If I gave you a piece of paper with just strange cryptic characters written on it that happen to look like this, okay? And I'm telling you, those are characters, not numbers. They are characters. If I gave you that, how would you translate that foreign language into a number?
Well, you will find out what position it's at, and then change it back into a regular integer.
Okay, so the reality is this guy is actually 1 times 100 plus 2 times 10 plus 3 times 1. So this guy is in the ones place, this guy is in the tens place, this guy is in the hundreds place. Make sense? We've all had first, second grade math. I think we did the long division came in 3rd grade, right?
Yeah, probably. I went to MPS, so
MPS, so you still haven't had first or second grade math.
I don't know. It was okay back then.
Mm.
Or
Not that old. How are you?
23.
You remember MC Hammer at 23?
Yeah, my mother.
Like
is
she
old
had
school.
like an old cassette tape hanging around.
She even has the records still.
See, I remember MC Hammer when he was like new.
You're just old.
I know, seriously. I had a junior high teacher, and we had like every Friday. I think I don't remember what they called it, but it was like a recess. Like you had to be good all week to earn your way into this thing. And every single week they had a drawing where they gave away a prize, and one of the prizes was a Mick Hammer tape.
Sweet.
MC Hammer,
Yeah.
Mick Hammer, but it was a cassette tape. But when I was a little kid, it was 8-track. Have you ever seen an 8-track?
Yes, I
Like in a
have.
museum?
No, actually, my mother had them. So, Motown, all that stuff.
What was I talking about? Oh, yeah. So we're just doing numbers, right? So we need to start at the end of the string, and this is the ones place, and then this is the tens place, and then this is the hundreds place. So we're just going to keep track of the place and keep multiplying it by 10 as we move towards the front of the string, right?
Okay.
But then we need to be able to take that digit and convert it into a certain number. So if I have the char 3, how do I get the int 3?
Set it equal to an int.
No, that won't work.
That child adds.
You can't
Wait.
cast it.
I don't know what. Oh yeah.
So I'm asking you, if I gave you this, how do you turn that into that?
You can take it as integer and minus 48.
Yeah, you can do it Unicode. You can do Unicode math with it. But we're not even going to do that. We're going to write another method. Static int char to int. This guy's going to take a char c as a parameter. And we're going to say if, we'll just write this stupid easy. So we're going to say if, I'll come back and rewrite a bunch of these things in a much cooler way at the end of class. I'm going to show you how this was actually trivial, all this crap. What was I doing?
Changing
Char to int.
Char to an int.
Okay, so if c is equivalent to a 1, now here, we'll start off with 0, because that's what the cool kids are doing. Return 0.
Keep doing that.
Else if it's a 1, let me copy it all first. 2, 3, 4, 5, 6, 7, 8, 9.
No wonder why you wanted all that space.
Alright, so that's a 0. This is a 1. Return a 1. A 2. Return a 2. Uh-oh. Better save real quick. Looked like Eclipse was starting to hiccup a bit. A 3. See, Eclipse can't even handle my programming. It's too powerful. Like, secret weapon. 4. Return a 4. 5. Everybody relax. 5. Return a 5. Man, such an easier way of doing this. I can't even believe I expected you guys to do this. This is like so much fun. I feel like I'm like in kindergarten playing with little blocks and stuff because I have to think like this little simpleton ways.
I'm glad this stuff is kindergarten.
The other way by chance, Carson.
Huh?
Yeah. I was
Yeah,
about
there's
to
all
use
sorts
that.
of other ways that you could have done this pretty easily.
Yeah, I was gonna use parson.
I'm going to show you those things. I'm going to give you new tools for your toolbox today.
Yeah, but see,
But not yet.
I was gonna use it before you even taught it, but then I didn't want to.
You want to cheat. You don't want to cheat.
It's not cheating. It's called research.
Well, no, but that's why I
Google
specify. I specify in all my assignments that you can only use what we've learned in class.
I know, and that's why I didn't.
That's why it's so fun.
It's like
At the beginning of every class, I have to go and look what assignment I'm going to give you to make sure I at least give you enough to solve it, because it's so much fun. Especially when I give you a hard program, but I don't give you enough, so it's literally impossible to solve.
We're crying at night.
Right.
Yeah, from laughter.
No, we are crying at night.
All right, so that's what this guy does. This guy takes in a char and returns the integer version of that char. We don't have any error checking in here, so it just assumes that you pass it a char that's either a 0, that's a 0 through a 9. Okay, I'm gonna just compress that down. It's like minimizing. It's still all there. Okay, so now we're writing our string dude. String to int. Okay. So we're going to keep track of the place. So we'll start at the ones place, right? We're also going to keep track of a sum, because we just had it up there. We're summing it all up, right? We had 1 times 100 plus 2 times 10 plus 3 times 1. But we're starting at the ones place. That way we can accumulate up from 1 to 10 to 100 to 1,000 to so on and so forth. So that means we actually need to walk our string backwards. We need to go from the end of our string towards the front of our string, because the only thing we know for sure is that the ones place is at the end.
Okay.
That makes sense? We only know for sure. We don't know how long our number is. We don't know, what we're dealing with right here. You can figure it out, but you can go and just say, well, since it's this number of characters. But if we start with the ones place, then we can just keep multiplying by 10, multiply by 10, multiply by 10, multiply by 10, multiply by 10. Okay? So we're going to need a little loop for int I is equal to s dot length minus 1. That's the last legal position in our string. Keep going as long as I is greater than or equal to 0. I minus minus each time. And what are we going to do? We're going to say sum is equal to sum plus hello dot char to int s dot char at I.
So
And return sum.
wouldn't place be 10 instead of 1?
Well, it'll be 1 the first time, and then we'll say place is equal to place times 10 each time through. So the first time it's 1, then it's 10, then it's 100 as we walk towards the front of the string. Okay? So let's test this. System.out.println hello.string to int 123, and we'll run this, and we should not be able to tell that it did anything until we go and add 1 to it, and we see that it magically gives us 124. Make sense?
Oh my god.
So now remember, probably first day of class or something like that, I probably referenced a movie. What About Bob? I referenced that movie?
No.
Really? I always reference that movie. How many of you have seen What About Bob?
None of us.
You knew who MC Hammer was.
Yeah, but I ain't hear about no what about Bob. You gotta remember, I grew up in the hood. I knew all of the hood stuff.
Yeah, well, this is a hood thing.
Really.
Yeah, Bill Murray.
It don't sound like it.
You know who Bill Murray is, right?
Absolutely not.
It's one of the Ghostbusters.
Once again, hood.
Just killing me. Well, anyways, there was a movie called What About Bob, and in the movie What About Bob, there was this guy, Bill Murray, famous guy. In fact, no, we're not accepting this. No, we're not gonna watch it. I'm gonna. You know who Bill Murray is? That's Bill Murray.
That dude.
He's like a famous person.
He's old.
Well, he's old now.
Yeah.
He wasn't when he was a Ghostbuster. He was not so old. He was like Matthew McConaughey type. he was.
He wasn't at you.
Hey, when you're a dude, he is.
I'm sorry. It don't work.
All right, so in any case, this movie was called What About Bob? And Bill Murray character had like some social anxiety issues. Okay, he everywhere he went, he had to like use handkerchiefs to open doors and stuff like that. Like his whole life, he was very disabled because he was so afraid of being everywhere.
He was a germaphobe.
Beyond that, he had everything. That's what the movie was about. The movie was that this guy had so many problems he couldn't even function. Well, in any case, his shrink, psychiatrist, was played by Richard Dreyfuss, another famous person. So, and anyways, his shrink was like completely full of himself and stuff like that, and had written a book called Baby Steps. This is where it comes in here. So he was helping Bob, which was the Bill Murray character, get through his life by taking little tiny baby steps. That was the name of the book, and the guy, was signing a copy for him, was totally full of himself. Well, and the movie gets hilarious because the psychiatrist goes away on vacation with his family to Nantucket or whatever, And Bob is doing so much better after he's following this book that he travels up there and basically haunts this guy for his entire vacation. But it's actually a very interesting movie, and it stuck with me. But the reason I always bring it up in programming classes is this concept of baby steps. If you try to tackle a big problem as a big problem, it will be very difficult to do it. If you try to build a house by just saying, I'm going to wake up today and build a house, that seems daunting. But if you wake up and say, you know what, I'm going to build one wall. But before I can build one wall, I need to nail these two boards together. How do I nail these two boards together? I need to take a hammer, I need to take a nail. You break it down into little tiny baby steps, and you start adding those things together, and all of a sudden you've built a house. That make sense? So, and another statement I say pretty often is that all hard programs are made up of a bunch of easy steps. If you were to look at the source code of Windows 8, you would see the same crap we're seeing here. Just a lot of it. Thousands and thousands and thousands of lines of it. But it'd be still all the same easy crap. You know, if you look at somebody who built a little shack house or a mansion, don't you think the insides of those things are identical? There's just more of it for the mansions. So, this idea of baby steps, I really want to get across to you guys here today. And hopefully you're kind of seeing as I'm belaboring, writing all these little tiny methods that we're using in conjunction and solving problems in terms of these new little tools. We ran out to Home Depot and bought this tool. Ran out to Home Depot, bought another tool. So we got two tools here. One's called char to int, the other one's called string to int. We can use those tools for a bunch of different things. Yeah.
Now, what if you put an operand or operator, whatever, inside the string?
Right now?
Yeah.
Bad things.
Okay, then.
Yeah, well,
Can we go through that?
Oh, no, we're getting there. I'm not done.
Oh, you was talking like you were done. Okay.
No. We've only written a couple of little widgets. No, we got a couple of little tools. We haven't built a house yet. We got the nails and the hammer. we got a house to build.
I'm a big dreamer. I want the house now.
All right, so we got that tool. All right.
And the ring, and the key.
Right.
All right, so what problem am I solving? All right, so we technically have this first problem solved here, but we don't really have it solved because we haven't written a method yet called process expression that takes in a string. Once we write that, we technically can handle a thing that has no operators in it. Correct? Mm-hmm. Okay. Now, let's start writing process expression. Hello.
Whoa, we didn't get rid of all our stuff.
Our world just about ended.
Don't do that.
Hello.
Song or
Did I say it should print out or return? The method should then process the expression and return the result as an integer. So notice that this guy returns an int as opposed to our previous methods that we wrote down here, which return nothing because they were printing a result.
yes.
That make sense? Mm-hmm. All right, so this guy's going to actually boil down to something. All right, now, in every single one of our examples here, what is the first thing we run into in those strings?
A number.
A number. So we read in a number, and it's a number until we hit what? Until we hit a space or we hit an operator. If we hit the end of the string, we're dealing with, we just finished reading in a number. So we need to be able to read in numbers. So let's start with that. So I'm going to create a string here called kernum. And we'll start kernum off at the empty string. All right. And we're going to need a counter here in a second, or some kind of variable to accumulate our answer in. But for right now, let's just start it off. Then we're going to have a loop, and this loop's going to go through our string. I equals 0, I is less than s dot length. I plus plus. Okay, so this loop should walk through all the indices in our string. Now, as we're looking at that, as we're looking at each character, so for instance, if I am currently looking at, let me just take one of our examples here. Let's use this guy. So let's say this is my string. Let's say this is S. I'm going to start off here at bucket 0. Am I looking at a space?
No.
Am I looking at the end of the string?
No.
Am I looking at an operator?
No.
So what must I be doing?
Looking at the integer.
I must be in the middle of an integer somewhere, right? So I should be building a number. My first goal in this particular guy should be to build the string 125. That make sense?
Yep.
And after I build that string 125, I need to save it as an int, right? So cur_num is what I'm building. So we're going to start off with that. Now I'm interested in whether or not I'm looking at a space. I'm also interested in whether I'm looking at an operator. So if s.charat I, if that guy is equivalent to a space, or he's one of the operators,
Yep.
right? Well, so let's write a little function up here. Static Boolean is operator, takes a char c as a parameter, and returns c equivalent to plus or c equivalent to minus or c equivalent to times or c equivalent to divide. Did you have to do modulus or no?
No,
I don't think
but
so.
I added it.
Okay, so we'll leave it at that. Plus, minus, times, divide. So it's going to return true if c is any one of those guys and false otherwise. So if I'm looking at a space, or if I'm looking at a operator, what just happened?
You're supposed to go to the next
So
space.
let's kind of walk through this as our example. So am I looking at a space?
No.
Am I looking at an operator?
No.
Nope. So keep going. Space?
No.
Operator.
No.
Space?
Yeah.
Not yet.
Oh, no.
I just highlighted the 5.
Oh,
The
okay.
space, operator, no. So I'm interested in whether or not I am not looking at a space. So we could even do it like this. So if I'm not looking at a space and I am not looking at an operator. If I'm not looking at either of those types of things, what should I be doing? I should be building cur_num
Kernel equals kernel equals.
yeah.
Well, what about the string to int?
Baby steps.
Um,
Baby steps. Don't get ahead of yourself. All right. So, if I'm not looking at a space and I'm not looking at an operator, we're going to be building up cur_num. As soon as I run into a space or an operator, that means I just fintished. See, I told you I'm an infant. I need my sippy Mountain Dew. All right, so if I just finished reading in a number, I'm probably going to end up converting it to something. But for right now, we're just going to do system.out.println cur_num. Just spit it out, proving that we just read in a full number. And then we're going to say cur_num is equal to the empty string. Empty it out. So we're prepared to read in another number. Okay? Now, the very last time through, since our very last thing in here is a number, right? And we won't hit a space or an operator. We'll actually run off the end of the string. So we know at the very end, we actually will have a number trapped inside of cur_num. So we can go ahead and print that out at the end. So our hope is if we run this method right here, and just for right now, just so it's we'll compile. I'm just going to return a -1 because this guy expects me to return an int. I'm not doing mathable stuff yet. All right, so if we pass it this string as our input, we should see 125 printed on one line, 7 printed on the next line, and 2 printed on the next line, proving that we got each of those 3 numbers, well, as strings. So let's test that. So there's our 125, there's our 7, there's our 2. It is kind of interesting that it's spaced out so much.
Because you say L space.
Oh, who?
You add more space.
No, this is the empty string.
Oh.
How we counting in all those spaces from the space and operator?
You shouldn't have. Oh, it did. When we hit it twice in a row. So build that up, build that up, build that up. Then we hit a space. So since we hit a space, print this out, and then 0 out a number. Then we hit this guy. So that's it. Printed out It didn't print out a space. It printed out an empty string and kicked it down a line. So that's why I did it. So we're fine. We are only capturing our 3 numbers there. Okay. In fact, actually, wouldn't it be easier to solve this problem if we removed all these spaces and only just had things separated by operators? Let's write a function for that. Static voil static string remove white space. Takes a string s as a parameter. String new string is equal to the empty string. For int I is equal to 0. I is less than s dot length. I plus plus. If s dot charat I is not equal to a space, then we'll keep it. New string is equal to new string concatenated with s dot charat I. And then ultimately return new string. So the very first thing we'll do in here is we'll say s is equal to hello dot remove white space of s. Now it should look more bestest. All right, so we went through, and all we did is we walked through the string that looks like this, and we said, is that a space? No, so keep it. Is that a space? No, so keep it. Is that a space? No, so keep it. Is that a space? Yep, ignore it. Is that a space? No, so keep it. Is that a space? Yes, so ignore it. Space? No. Get it? Haha. Okay, so now we have a way of making sure we have the white space out so we don't have to worry about that kind of stuff. So again, another little baby step to make the problem a little easier to solve. So we are building up our numbers inside of kernum, and we already have the ability to take kernum and turn it into a real number, right? We can turn that string into a number. So I'm going to have a int running total is going to start off at, no, do I want that? Yeah, we'll start off like that. So running total is that we'll have cur int and char cur op. So at any point in time, we're going to have our a current integer and a current operator that will apply to that integer. Okay, so inside this if statement, we're building our number. When we get into this guy, we have a number. So what are we going to do with this number? We're going to say if let me actually start running total off at -1. That's fine. If running total is currently equal to -1, which means that we haven't actually put a number in there yet, then what we're going to do is we're going to set running total equal to hello dot string to int of kernum. Else actually, let's do this a little differently. Right now, our guy is guaranteed to look like something like that, right? We'll do it this way. We can leave that as -1. I'm going to have cur op start off as a question mark. So question mark means we don't have an operator. So now what we'll do is, if our running total is currently -1, we don't even need to ask that. What we really are interested in is this. If cur op is equivalent to a question mark, then we're going to go ahead and set our running total equal to the current number. That means we just bumped into it for the first time, right? So that's why we don't even need the -1 here. We're going to give it a value. We're going to give it a value right here. Okay? Now, otherwise, cur op must be an actual value. And if it's an actual value, that means what? If it's an actual value, that means that we have an operation to perform where we take whatever is currently in running total. So I can actually get rid of current here. Whatever's currently in running total and perform that operation on whatever's currently in num, what's it called, kernum? Whatever's in kernum. So we need to be able to perform an operation on two numbers. So let's write a little function. Static int perform op. And this guy is going to take in a char op int num1 int num2. So three different parameters. And we'll say if op is equivalent to a plus sign, then we'll return num1 plus num2.
It has three numbers like your.
We're getting there. Okay. We're getting there. Else, because this is just for one of those. So this is just for saying 125 plus 7.
Gotcha.
Then the next time we'll have 132 minus 2.
Oh, okay.
Get it?
Yes.
All right, so if we're looking at a plus sign, return the two numbers added. If we're looking at a minus sign, return the two numbers subtracted. If we're looking at a multiplication, return the multiplied. If we are, otherwise, we must be looking at a division, num1 divided by num2. Okay? So that's what perform op does. Okay. So, if we actually have an operator, then what are we going to do? We're going to say running total is equal to whatever's returned by hello dot perform op, what op, cur op, on what number? Current running total. And what other number? Hello dot, is it string to int? String to int of curnum. Make sense? Oh, it does want us to give some sort of value to this guy initially, even though we know it's not gonna, we know we're gonna overrate it. Okay, but now we have a problem. At this point, we're never actually reading in operators. We're checking to see if there's an operator, but we're not actually reading them in. At this point, what are we doing? If we're not looking at a space and we're not looking at an operator, we're doing that. Now, as soon as we run into something that's a space or an operator, we have to deal with it. Do I even need to check for spaces anymore?
No.
Why not?
Because you took them out.
I removed them. I don't have spaces in my expressions anymore. So I can simplify that, right? I don't have to check for spaces. So basically I'm saying if I'm not looking at an operator, I must be looking at a number. So build it. Otherwise, if I'm in here, I must be looking at an operator. Is that an accurate statement? I must be looking at an operator. If I'm looking at an operator, what do I need to do with it?
Perform an operation.
Well, I don't. If I'm looking at an operator, I might be looking at this plus sign.
Oh, you did.
I don't have enough information yet to perform an operation.
Determine the operator.
I need to capture it. So if I'm looking at an operator, I need to say cur op is equal to s dot char at I. I must be looking at an operator, so capture it. That's what that line will do, right? But before I do that, if I'm looking at an operator, so for instance, let's say I'm looking at that operator. If I'm looking at that minus sign there, that must mean I've already captured this 125, okay? And I've already captured this plus sign. And I just finished capturing the 7. So before I overwrite that plus sign with a new operator, I need to do some math. So, if my current operator is a question mark, let's go ahead and let's set it. That means that it's my first number. So we'll set running total equal to my first number. Otherwise, we'll actually do the math and zero out our cur number. Correct?
You guys zero out your current operator too.
I don't need to zero it out. I just need to replace it. I know that if I'm in this else, I know that I'm looking at an operator. I just need to make sure I use the previous operator before I overwrite it with my new operator. Make sense? So when I get into this else, I'm looking at an operator. So for example, I might be looking at this minus sign. But before I overwrite my current op with that minus sign, I need to make sure I do the math for the previous op, the plus. Because that means I just finished reading in this 7, which now allows me to actually do the 125 plus 7. So I'll do the 125 plus 7 right here. Then I'll zero out the 7, zero out cur num because I've used it, and then overwrite cur op with my new operator. That make sense? Now, again, when we run out of this loop, cur num has a final number in it, correct? There's the final number in it. If cur op is a question mark, what does that mean?
You guys looking at the number.
It means that I was looking at something that looked like this. I was looking at one of these guys. Because I never actually hit an operator,
Right.
right?
Mm-hmm.
I just hit the end of the string. So when I come out of that loop, I have to ask the same question. If I have no operator, running total should just be equal to the number I just read it. Otherwise, give me my final running total. So really what we're doing here is get the final number. And then ultimately return running total. That make sense? Okay, so let's print this out. What should this guy give us? 132, 130?
132.
130. Print. All right, there's our 130. Now let's just do all these guys. So we have 125. Then we have 125 plus 7. Next one is 125 times 2.
Yeah, after that last one we got right there. No, leave that one right there. Then go down.
What?
It was after that.
Oh, I get it. I get it. What was that?
Yep.
And then divided by 3?
10.
10 divided by 3?
Yep.
All right, so we should get 125, 132, 130, 250, and 3. This is so nerve-wracking. So I told you it was easy. The best part is I had no errors. That was actually kind of a fun assignment, wasn't it?
It was.
No.
The last one wasn't
No?
a headache.
Not a fun assignment?
Not the last one.
Actually, I add something.
I think.
Like if we have 5 times 2 divide 2 minus 1. I did this.
See, now you're just doing too much.
Okay, so what do you want me to do?
No.
We're battle testing mine. What are we doing?
10 like times 3 minus 1 divide 2 plus 1.
Okay, well, that's going to be 30. 30 minus 1 is 29. 29 divided by 2 would be 14. Plus 1 should be 15.
As a method, no. As a mathematic, no.
Well, yeah, in this guy, yeah, it doesn't do order of operations.
Okay, that's
Yeah.
what I did. I mean,
You made it work for order of operations?
yes.
Yeah, so there's our
Still
15.
get 15.
Well, no, what he's saying is
Yeah.
you would do this first, you would get a 30. Then you do the 1 divided by 2,
Right.
which would give you a 0.
Yeah.
So you do 30 minus 0 is 30, plus 1, you get a 31. So 31 is the result you would have expected. That would have made this a lot harder. Well, not really that much harder.
That's exactly why he's doing too much right now. Yeah.
All right, so questions about any of this before I show you some easier ways of doing a lot of these things.
Yes. Yeah. I agree. Second.
Just get this feeling of desperation.
Yeah. I mean, you put something on us like that, and then you expected us to actually
You had a week.
a week. Oh my gosh, dude! Do you know how much homework I have? Not to say that yours is any less important.
But you had a week.
Thanks.
I just did a live performance while talking.
That's because you knew the answer.
I didn't know the question.
That's your fault.
What do you mean I knew the answer? When I walked in, I didn't know the question.
You just couldn't remember the question, that's all. You knew it, you just couldn't remember it.
All right, so I'm giving you all this crap.
Yes.
Please, thank you.
Very
You guys
much
are just going to
appreciated.
sell this on the black market. I know it.
No, you already got stuff on the black market.
Do I?
I don't know. Just figured you would.
Where can I put this crap?
Yeah, in a Word document on Unit 2 and say help.
Share content.
Add content. Can I do like a
Page.
Yeah.
create a new page of content from scratch?
Sure.
No, not that, because then it won't give you just like a Word document printed out like the homework looks.
What are you complaining about?
It'll look just like the homework pop-up
Yeah?
instead of having it as a separate document. Yeah, instead of it being an attachment, it'll look just like the
Yeah,
homework.
but you could just read this way instead of having to download an attachment.
It'd be better to download it than to sit there and try
Who
to
wants
go
to
back and
download? Here, you could turn it into your own document. What is this?
Fine.
Homework what?
forth. Homework 3.
Number 3 solution.
Mm-hmm.
There. Complete. Plus, it'll maintain formatting better like this too.
Yes.
I hit save. Trust me. Maybe not.
Or we just don't trust.
No, it doesn't need a subtitle. You think you're better than me? Huh?
Did you give it access to everybody?
Do, do, do. I wonder how many times that got saved. All right, let's go take a look at that. Homework number 3 solution.
Not,
You
can't
didn't make
see
it active.
Yeah, you have to make it so I
Just asked you about
No,
that.
it says everyone.
can't see it.
I'm gonna
Now
go
I
in.
can.
You can see it.
Yeah, now
Did you refresh your page?
I can. I did. Like I just logged in right when you did, so it's fine.
All right, so it's there. You're good. It's legit.
Thanks.
All right, so let's. Oh, we need a break.
Alcohol.
Oh,
I mean-
a real.
You didn't hear that. Nor did the recorder catch that.
Let's see. Well, let's start off by making a couple of these things a little bit easier. So let's look at string to int. So I'm going to rewrite some of these things. So just so we don't have to change a bunch of other code, I'm just going to come into string to int. And it currently looks like this, right? Where we're keeping track of the place and all that crap. I'm going to instead just say return integer dot parseInt s.
I swear, I had that.
Now, one thing I'm going to specify. This is the only version of parseInt I'm showing you.
There are multiple.
There is another version of parseInt that would be shockingly helpful for your next homework assignment. Can't use that one. It's the only one you can use. Okay, so now, here's what is parseInt in this example? This line, what's parseInt? What kind of animal is that?
That is a method
Method, how do you know?
because it is attached to a class
Mm.
called integer.
No, because it's that like last sequence.
Because of who?
Say because it's italicized.
You call it. You call it like that.
How do you know at a glance that this guy is a method? I don't even care what kind of method he is yet. How do you know he is a method?
Because you just put a parameter in
Because it's coming.
Parameters. Because you have opening and closing parentheses. That's what makes him a method.
Boom.
Okay? So, now, class method or instance method?
That a class method.
How do you know?
Because you have integer.
Okay. Not because we don't see static or we see static. This is it being used. So static versus non-static is when a method's being defined. In this case, we're seeing a method actually being called, being used in the wild. How do we know it's a class method? It must be a class method because we're calling it with the name of a class rather than a instance of a class. Now, realistically speaking, you don't necessarily know that this is the name of a class. Two things should cue you in on this. First of all, if this line works, it must be a class because I don't have a variable in here called integer. So there's no variable floating around here called integer to work with. So it must be the name of a class. Secondly, because of naming conventions, classes typically start with a capital letter. So the capital I kind of is should make us highly suspicious that this is the name of a class. Make sense? Okay. And what this guy does is he takes a string in as a parameter, and as long as that string holds the contents of an actual number, it will boil down to the int version of that. So this guy does exactly what our string to int method is supposed to do. That make sense? I'm going to show you another cool tool that will be helpful. The index of method. This is an instance method in the string class. There's two versions of it. One takes a character as a parameter. The other one takes a string as a parameter. Either one of these returns the position. Here, I'll actually, the zero-based position within the calling string where the parameter first occurs. For example, if I have string s equals hello, s dot index of h would boil down to a 0. Index of e would boil down to a 1. Index of L would boil down to a 2, because the first occurrence of L is at bucket 2, even though it also occurs at bucket 3. Make sense? Now, the most important part of the behavior of this method is coming up right here. Most important part. Even though it's probably going to seem like the least important part. But from a problem-solving perspective, it's the most important part. What if I said index of Q?
It's going to give you the number.
Is Q in there?
No.
It returns a negative 1.
So it won't just go through the alphabet and pick out what.
No, boils down to negative 1 if the character or the string you are looking for is not found. Negative 1 means I did not find it. Make sense?
See that quick is not. Is this case
Yes, case sensitive. Is that an Android tablet? What is that? iPad?
Yeah,
Oh,
remember
oh,
when
just
it was
it just has the weird. Is that a Mickey Mouse case?
Mm-hmm.
Yeah. No.
Sticker.
Yeah, no.
It's a Mickey Mouse
Okay. So, questions about index of? Everybody thinks they understand index of? Can use it? So let me give you a couple of examples up here. And then it's quiz time.
Huh?
Oh, yeah, it's gonna be so awesome.
Haven't you fried our brains enough?
What do you mean? You fried my brain. You haven't done crap. All right, so we're gonna say s dot index of and h. So here we'll do the L twice. We'll do an O. We'll do a space. We'll do the string space. We'll do the string world. And then we'll do a Q. And we'll do a string Mickey. Mickey Mouse. All right. So H should boil down to a 0. 1, 2, 2, 4.
3.
No. First
Oh.
occurrence of L.
Oh, gotcha.
Right? So 0, 1, 2, 2, 4, 5, 5. First occurrence of the string space is at bucket 5. 6 will be the first occurrence of the string world. So it's the beginning of it. -1, -1.
Interesting.
Make sense?
Yes.
Any questions about how that works before you get your quiz? Which will involve index of. All right, everybody take out a piece of paper. And get your name on it.
I'm gonna be as nice as to not rip it out.
No computers for testing. I'm gonna start eating my food.
Ooh.
No computers for testing. See the is operator method there? Rewrite that using index of. When you're done, come up here, hand it in, and you can go take a 10-minute break. Rewrite is operator in terms of index of.
In terms of index.
Use index of to solve that problem. Man, what's in all this stuff?
Which problem? You didn't give us a string.
What are you talking about? It's right here. Here's a character. Is operator returns true if this character is either a plus sign or a minus sign or a multiplication sign or a divide. That's what this method does. This method returns true if the operator is an operator and false if it's not. So if I passed the question mark in there, it would return false. If I passed the letter A in there, it would return false. If I passed a plus sign, it would return true.
Instead of the true,
It's more
you're
in
looking for the index of that.
What's up?
Instead of true, you're looking for the index.
No, I want it to have the exact same result. I want a second version of this method that is literally functionally equivalent to this method. It has the exact same output given the same input, but I want you to implement it using index of. Who?
Yeah,
Rewrite this with index of.
that is a very vague and very strange question.
See this line right here?
Yes.
That line must have a call to the method index of in it. I want you to use index of inside this method to solve that problem. Instead of a bunch of ors. Hint, hint.
Nudge, nudge. Gotcha. Okay.
Let's see what all I get. What all I get here? Oh, is there chili on one of these? Oh, this is a chili dog.
It's cold now.
Who cares? Who even cares? Mm-hmm.